some ways, the core point is there are many risks from AI and not just one. And so we should not expect a magic bullet here any more than we should expect a magic bullet for making AI. We're not going to get one existing law that covers all of this. Agility is probably the most key thing, right? AI will change. Even if I think we've reached a point of diminishing returns for now, someday it will advance, right? It's a matter of having conceptual advances and so forth. They might happen this year, they might happen 10 years from now or 20 years from now, but they will happen. We need agility in how we manage this. One important thing is we need transparency. We need a full accounting, for example, of what data is used to train the current generation of models.
OpenAI is faced with a problem. How are we going to make money off of this stuff? And it's not cheap, right? I mean, they've probably spent, $10 billion on data and chips, and they're going to spend another 10 or whatever. I mean, GPT-4, who knows how expensive. They need to make money, or they will either go out of business or Microsoft will take a bigger chunk of them. And it's not clear that VCs are going to want to up their valuation to $200 billion given the kind of picture of revenue that is emerging. And so if I were Sam Altman and I had a different kind of morality than I think I do, first thing I would think about is surveillance, right? People are giving them all this data on a silver platter. Now you got a camera too? That's the natural direction for the company to go, despite their name, quote, OpenAI, right? I mean, it's a really sinister thing for them to do, to become Big Brother. And did I mention they're still a nonprofit, which is insane? So we may very well wind up with the world's largest surveillance company as a wholly owned subsidiary of a place that calls themselves OpenAI that's nonprofit. That is, I think, almost a default outcome right now. That's, to me, upsetting.
The Brave Search API brings affordable developer access to an independent index of over 20 billion web pages. Well, it's built from scratch, without big tech biases, powered by real anonymized human page visits to filter out data, and refreshed daily with tens of millions of new pages. Perfect for AI model training and retrieval augmented generation. Whether you're working on language models or information retrieval systems, Brave offers representative datasets and up-to-date information affordably. We'll get started with 2,000 free queries monthly at brave.com/API.
We've had quite an assemblage of exciting and in-depth keynotes at the event, but I have to say the next one is one of those I've been looking forward to the most, which is Gary Marcus will be talking about his thoughts on how to move toward a proper foundation for robust AI. And like a number of us at this event, Gary has been thinking about how to make thinking machines and about how human thinking works for quite a long time, and long before it became such a popular topic as it is now. So he was pursuing this research and thinking at NYU for some time. He founded a company, Geometric Intelligence, that was later acquired by Uber. He was working on a robust AI. Has written, as well as an amazing number of journalistic articles on AI-related topics, some outstanding books. So rebooting AI from a few years ago is still highly pertinent to the current situation regarding AI. His new book, Taming Silicon Valley, I have not read yet, but deals more with the regulatory and the social aspects of AI, along with considerations of how to actually make AI work. So Gary had given a keynote at AGI 2021, and we're honored to have him back again. And as well as hearing what he has to say, it's interesting to look back and compare and contrast where we were in 2021, where we are now. And I think compared to many of the other pundits out there, I would say, Gary, your analyses and prognostications have proved fairly often on target. And we've seen that in some of your public dialogues with Jan LeCun and others, as well as in more depth by looking at what you've written. So I think you've been quite insightful not only into what is happening, but into what is going to happen in the AI field. And so this is a keynote we should all pay close attention to. Thanks, Gary.
You're very gracious, especially compared to the aforementioned Jan LeCun, who has never acknowledged that the things that I said that he used to argue against, he now sees as true. But that's a story for another day. Or for drinks later. So I changed the title of the talk from the title of my forthcoming book, Taming Silicon Valley, which I will mention, to Towards a Proper Foundation for Robust Artificial Intelligence Redux, precisely because I had given a keynote here. It occurred to me 3 years ago. Of course, 3 years ago, I did it virtually, and I wasn't getting on any airplanes then, and it was pandemic, so I am glad that that part of the world has changed. But I'm going to actually look at the talk that I gave 3 years ago. I've never done this before. Maybe it'll be annoying. I didn't test pilot in front of everyone, but I think it's really interesting to think about where we are conceptually in AI now. We all know a lot has happened in the last 3 years, but I'm going to try to argue that we're still actually in many ways stuck in the same place. So I'm going to actually show you some slides from a few years ago. So the talk then was called Towards a Proper Foundation for Robust Artificial Intelligence. And I talked about the idea of a foundation model, which hardly anybody had really heard of yet. But Stanford had just come out a month or two before I gave the keynote here with this thing about foundation models, and the term caught. They wrote this long 150-page paper with 150 authors or something like that. And well, the first thing I had to do was to say, what is a foundation model? I don't really think I need to do that now, but I talked about GPT-2 or 3 or whatever was around at the time. I guess it was 3, and DALL-E. And that's sort of how I started the talk. And then I referred to a paper I had just written in The Gradient with Ernest Davis, my longtime collaborator. And I think it's actually worth looking at that paper for giggles. It was in The Gradient, and it was called Has AI Found a New Foundation? And the key of that early part of the talk was to say, well, what do we mean by a foundation model? Well, a foundation model, well, what's a foundation? It's a bedrock that you can rest on and rely on. And so I made these arguments. I said, look, you can't really rely on GPT-3 or DALL-E. They make all these kind of stupid mistakes. And at the time, I think people thought these things were miraculous. And some people said, yeah, okay, they make a few stupid mistakes, but we're going to add some more data and it'll go away. It's not really a problem. So anyway, I was kind of laying that out. And I was also calling attention to some of the worries that I had, like misinformation. So somebody asked one of these systems, did Bill Gates invent COVID-19? And it says he sure did, which isn't really true. And is the vaccine dangerous? Blah, blah, blah. And it says it's not very effective. It turns out it was actually phenomenally effective. And then I gave examples from another system. People may not remember, but it was a very pioneering system called BERT. And I showed an example from Alice and Edinger, where I showed it basically didn't really understand negation. And this was, forerunner to modern problems. I said a robin is a blank, or sorry, she said, that's even worse than the royal we. I didn't do that work at all. But anyway, she did that work, and she showed that a system said a robin is a blank, and it came up with a robin is a bird. But she said a robin is not a blank, and it also came up with a bird. And that's kind of a sign that these systems are working on things like frequency rather than semantics. They don't really have very deep comprehension, and I made all these points, and this was 2021. And I said, look, what we have is deep learning, but deep learning, and this is an actual slide I had then, refers to a number of layers in a neural network, not to the depth of understanding. And what we need is deeper understanding. And I showed an example where one of these neural nets looked at a picture of an elephant on a beach, and it said that the elephant was a person. And I did my usual stick of making fun of these systems. And then I had some more slides like this. I said, they're imagining in this LLM world that you have data and compute, you put it in a cranberry grinder, and out comes AGI. And I mean, we're here at an AGI conference. We're not here at an AI conference. We're not asking, can I use AI in my GPS system to find my way to the conference center? We're asking, are we getting towards AGI? And all these things are a problem. And there was already this trendy thing called scale is all you need. You could even get it on a t-shirt saying AGI is coming, interpolating it from some lines. And I guess a little bit after the conference, I wrote something saying, look, these things are not actually physical laws like laws of the universe. They're just generalizations we've seen for a while. They don't necessarily hold. And so even at that conference 3 years ago, I showed the t-shirt and I said, come on, don't believe this for a minute. There are actually deep structural problems here. And then I went on in this vein. I talked about why did it matter? And I said, well, AI has a big hype problem. You've got Hinton saying that we may as well replace or stop training radiologists. We're not going to need them anymore. And Elon Musk was saying that by the middle of 2020, Tesla's autonomous system will have improved to the point where drivers won't have to pay attention to the road. And I said, look, all of this is ridiculous. I had a graph showing that the number of startups working on radiology was like in the hundreds, I guess, or something like that. And the number of actual radiologists replaced was 0. That's the right bar on that graph in the bottom left. And, I gave some examples of accidents that full self-driving was happening. There was a wonderful piece, or a terrible piece, depending on your perspective, a sad piece by Will David Heaven in Technology Review saying hundreds of AI tools have been developed to catch COVID, but none of them actually worked. And so I had these kind of criticisms of the social impact of AI and how it was being overhyped. And I also point out that there were lots of problems with sexism. Again, many other people have done that work, but I gave some illustrations. I said that Mark Zuckerberg was being ridiculous when he said that Facebook was going to solve the misinformation problem with AI, which he actually told, nobody remembers this, or maybe a few people remembers, he actually told the US Senate that he was going to solve it in 5 years. I think he said this in 2019, 5 years have elapsed. I don't think he solved the problem. And then I said, look, the fundamental reality of contemporary AI is that deep learning works well with routine things, but poorly with unusual cases. So I said, in the regime of small data, you can't really count on this approach that has become wildly popular. So what happened? Well, sorry, one more thing. And then I said, look, and this is paraphrasing an old quote, but updating, I said, deep learning is a better ladder. I actually said this in 2012, but a better ladder doesn't necessarily get you to the moon. And that was kind of the take home of the first part of my talk in 2021. And then, what happened is large language models became vastly more popular. Nobody listened to what I was saying about, you have problems with outliers and stupid errors. And they're like, oh, come on, Gary, we need to solve that. We got that covered. We just need more data. And they got more data, and they made GPT-4, and GPT-4 was amazing. So where are we 3 years later? Was Gary totally off his rocker? We got all that data, how's it going? Well, first thing on the plus side, maybe it's a plus depending on your perspective, large language models have become ubiquitous. I should say I wrote this talk last night and this morning because I thought, hey, I was here 3 years ago, so there might be a few bugs in the system. But anyway, so I said, look, large language models have become ubiquitous. They found a home in coding and brainstorming, not to mention writing student papers, which is, again, not a total plus, but if you're a high school student, you might love it. And they became wildly known throughout the world. And people have made zillions of them. Every dot up here is like $100 million experiment. It's kind of science, right? Everybody is testing, whether they admit to you or not, the hypothesis that scaling is all you need to get to AGI. So every one of those dots is an experiment. There's like billions of dollars of research are graphed on here. And there's $50 billion of chips purchased in the last 12 months or something like that. It's a very expensive experiment to look at the scaling is all you need. So have they solved any of the problems that I was ranting about the last time I spoke before you 3 years ago? Well, you can guess where this is going. In many ways, we're in the same damn place, but with much better graphics. So. This is why you should do your talks many times, so you know where the laugh lines are to get the timing right. All right, so on the left we have, make a picture of a heavy metal band with people of different ethnic backgrounds. There's a lot of fun stuff on Twitter yesterday about the different, it's not ethnic backgrounds, but prog rock and so forth. So, so this is problematic. I want to point out, because it kind of pisses me off, that it's exactly the inverse of the Google woke stuff that so many people were exercising about. There were billions of people writing about how Google was too woke. And I mean, it was too woke when it made, the founders of the United States all African Americans when, actually they didn't get that vote and so forth. But we're getting the same stuff here in the opposite direction. Nobody's saying a word. Nobody's or hardly anybody saying a word. Okay, here's another example. Draw a picture of a beach without an elephant. We still have exactly the negation problem that Allison Ediger pointed out in 2020. And in fact, somebody sent me an old video of Jerry Fodor that was filmed around 1990 pointing out the same problem with negation. And I've mentioned it numerous times in my work in between. It's still there. The yahoos on Twitter say, well, if you say think of a beach without an elephant, I'm going to think of a beach without an elephant. And that's true. But the command here is draw, not think, right? And if you asked any artist in the world to draw a picture of a beach without an elephant that came back with an elephant, you would fire them. So it's not the best excuse, but it's a common one. Okay, here's one from my friend Phil Lieben. He was the founder of Evernote. Make a sightseeing map of the US, this is with Grok, highlighting, actually Grok was so bad I didn't even put it up. This is with ChatGPT. Make a sightseeing map of the US highlighting the most famous tourist attraction in each state. You will see that the Grand Canyon is very popular in places that aren't Arizona. Disney World is all over the map. Florida is now in the middle of the United States. Mount Rushmore is now, I guess, well, yeah. So this is a information. It's very hard to give a talk you haven't given before. This is an information integration problem, right? What is AGI? I didn't define it here. I think Ben helped define it originally, and I think of it as like at least human level performance on a bunch of tasks, like pretty much all tasks, even tasks you haven't done before. There should be flexibility, and certainly you should be able to integrate information. I mean, like, I don't see how you could call something AGI if it can't basically do a join in a database with an image. Like, that's just not AGI if you can't do that. And here it's just dreadful. And the dreadfulness is partly driven by frequency effects, like overemphasis on frequency. It's putting Grand Canyon up because it's a popular tourist destination, so it's putting up everywhere. Same thing, it writes, well, I've seen a few differences with it puts Rushmore in a bunch of places because it's popular, and it really doesn't know where the Statue of Liberty belongs. Like which code, like it doesn't actually understand geography. It doesn't really know that, it should be a one-to-one thing where each state has its own thing. It's really just out to lunch. I posted this on Twitter. People love to send me examples now, so I don't have to play with these things so much. I can't actually get AI overview to work for me in Canada. But somebody said, how long, I've gotten a few of these, how long is a train ride from New York to Rome, Italy? They didn't just say Rome, they were specific about it, to Rome, Italy, and they got the answer, a train ride from New York to Rome, Italy is about 4 hours and 48 minutes. And so I posted on Twitter that I'm learning a lot from Google AI. Now, not every error is made by every system all the time. So some systems will actually get this right, and some will get it wrong. But the point is there is absolutely zero reliability. You cannot count on these. And again, I would say that you are not at AGI if you're confused and you take the information that you know about Rome, New York, and conjoin it, or I don't even have a verb for it, with the information about Rome, Italy, and forget about the Atlantic Ocean and all of that. This is what I did this morning. Kind of still worried about the sexism issue and just how dumb Grok really is. And so the part on the left we'll get to, and then we'll get to the part on the right. So I asked it, please make a drawing of the current Prime Minister of Italy, the actual person in office right now. And this was my second iteration because the first time I just said, please make a drawing of the current Prime Minister of Italy. I posted on Twitter and somebody said, but you didn't say the actual person in office right now. I'm like, all right, you gotta be kidding me, but okay. So I did it, I added it, the actual person in office right now. And 4 tries, 2 of them were very frequently displayed former leader of the United States. And I'm sorry, it sort of cuts off. And I think 2 are just random people, but I don't know everybody, so maybe they're not random people. But none of them are the current Prime Minister of Italy. Who is actually the current Prime Minister of Italy? Well, somebody said, well, it's a lag issue. There's a training lag issue. But the actual Prime Minister of Italy is Giorgia. That's a female name for those who don't know. Giorgia Meloni, who has been in office since 2022. And if you ask Grok in the text mode, it knows that. So it's not a lag issue, it's a stupidity issue. It's an issue that it doesn't, that one hand is not speaking with the other. All right. I think I've made my point. but there were some other things I talked about before too, and those big ticket items still haven't been delivered. Like, driverless cars have made progress since 2021. Some of that progress has been winnowing out the bullshit artists, so we have fewer companies. And, but you know, they're actually in demos now. But they are still demos. I was actually very excited to read yesterday that Waymo is finally going to try to deal with snow. Like, that's cool that they're finally trying to deal with snow. But roughly speaking, we have about 15 cities where you can take a genuinely driverless car. And mind you, what we learned from Cruise is that, quote, genuinely driverless cars that have no driver in the car still have remote operations. Cruise had more people in the remote operations than they had cars on the road. Waymo hasn't published that number. But at least for whatever Waymo is doing, those are genuinely driverless cars in the sense there is no driver in the car. But you can only use them in about 10 cities. And no, you know, rural areas that I know about. I looked up how many cities there are in the world, not using a chatbot, and got the answer of 10,000. So, you know, your chance of being actually able to use a driverless car, if you don't live in the Bay Area or in Arizona, is very low. So it's still a demo. We still don't have them on the road. You still need to pay attention if you're in a Tesla, et cetera. The radiologist, I asked for a check from a radiologist or a medical friend who knows radiology well. I said, last I checked, there's actually a shortage of radiologists, possibly partly induced by Jeff Hinton's propaganda, right? Because some people did, in fact, probably say, I don't think I should go in this field because deep learning is going to replace the whole thing. And in fact, as of June, we still have a shortage of radiologists. Okay. I didn't talk about economics when I was here. But I started thinking about economics a bunch when generative AI got to be so popular. But I couldn't really see the business model for it because of all the problems that we're talking about. It's just not inherently reliable, and so that puts an upper bound on how you can use it. And so I wrote this article called What If Generative AI Turned Out to Be a Dud? And I thank Dilip George for making me think of the Hindenburg as something that scaled fast but failed. And that was a year ago, and I think we're seeing signs that the economics are not so great. You have a lot of people who tried generative AI last year. I mean, basically every CEO on the planet called their chief information officer and said, how are we going to use this thing? Get it in the company right now. We need to tell our shareholders and so forth. So everybody tried it, but it didn't really work that well. And so a lot of people have, you know, they used it last year and they're already giving up. Some people are, some people aren't. I have been arguing that generative AI has been hitting a phase of diminishing returns. There is no cure for these hallucination errors where they just make stuff up. There is no cure for all of the boneheaded errors. And I've argued that more data is probably not going to be enough. We have fundamentally our systems that predict things that are likely relative to how language works, but they're not actually understanding any of the concepts that they're using. And now even some people who disagree with me are kind of noting some of the data for it. So Ethan Mollick is kind of like my inverse doppelganger or something like that. He's always giving the most optimistic read on everything that happens in AI, and I'm also often giving a more pessimistic one. And he says, look, there are 5 GPT-4 class models now, GPT-4o, Claude, blah, 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 blah. They're all saying that there's room left for great improvements. Talk is cheap. But we haven't actually seen anything significantly better than GPT-4. When was GPT-4 actually trained as opposed to released? Turns out it was August of 2022. This has been well documented. They showed it to Bill Gates and kind of changed the world. But 2 years, we haven't really got much better. And so I'm going to show you a graph I showed you before. There's a graph circulating. We don't have to go into why it was made. It's about open source, closed source models. But I took the liberty of trying to extrapolate a curve, because every day some AI influencer, aka grifter, I didn't say that out loud, I just thought it, shows you an exponential, or I mean, doesn't show you an exponential, they're all math enumerate, but they say every day, wow, I can't believe what came out this week, there's been exponential improvements, it's amazing. So I thought I'd actually plot a curve. I just did it by eye, I didn't do the math, but looking at Palm Chinchilla, which was the state of the art in April of 2022, and relative, this is to release dates when GPT-4 came out. And you could genuinely make the argument that we saw exponential progress over that period. It was pretty amazing what happened. This is all since I spoke here 3 years ago. There was a lot of progress, and you could argue GPT-4 was kind of an outlier, but there was a lot of progress in the period leading up to GPT-4. But is it continuing? So this is where the curve should go. There's a little glitch with that we can talk about. But this is where the curve, roughly speaking, should go. But in reality, scaling has slowed. So here's the full curve of all the data. If you're a scientist, if you know Bayes' theorem, if you know how to aggregate data in whatever statistical technique you want, you can look at this. Each data point is a test of the hypothesis. Let's say that scaling would continue at the pace that it did from Palm Chinchilla to GPT-4. And it is obvious, you don't even need to run a statistic, but you could if you like. It is obvious that scaling has slowed, that we are not, in fact, still on that exponential regime. There are multiple possible explanations for it. One is we don't have enough compute, maybe true, maybe not. A lot of companies are spending a lot of money. I'm not sure that compute is actually the bottleneck here. Another one, I think, is data. So, it was a neat trick to take 1/10 of the internet or 100th of the internet and then switch to having more or less all the internet. But you can't now throw 100 times the internet because that doesn't exist. And so there's not enough data to keep playing this trick of just more data in the cranberry grinder. And then I think there's an architectural problem. These things don't have representations of the world. And so there are always outlier cases, and we're just kind of running into that. Whatever the reason, I think scaling has slowed. And it's remarkable how few people have actually admitted that, and how many people keep still saying the word exponential without actually plotting the curve. Okay, the little glitch in what I had here is this is MLU. 100%, I added a line at the top. Obviously, we can't do better than 100. Well, actually, I have to think about the test. In many tests, you slow down near 100%. There are little glitches and so forth. So we have what psychologists call a ceiling effect, and so it's not really reasonable to expect 100% per se. But I think that the point still holds. There's still volume. But I actually did another test. I looked at NYT connections, this little game that my family loves to play in the New York Times, where you have to find clusters of categories. We're nowhere near ceiling on that. And we still find, I did this in April, we found that GPT-4 Turbo was barely better than GPT-4. So we don't have as thorough data for connections as we do for MMLU, but I think the point is clear. Okay. I just wrote this on Twitter out of absolute exasperation. In my entire career, I've never seen an experiment fail so many times at such great cost as the experiment on the scaling hypothesis that you could create AGI simply by adding more data and compute. It doesn't work. Can we try something different already? So what would be better? So I also put this on Twitter as a joke. Big secret revealed, because all these Twitter influencers do this kind of stuff. How you too can get from Grok to AGI in just 2 easy steps. Number 1, draw an owl. Number 2, draw the rest of the owl. So, the fact that we can do a little bit of this does not mean that we just follow the same procedures the rest of the way. And I actually talked about that stuff too in 2021. So we're going to do another flashback. In 2021, I talked about that book, which Ben kindly said is still pertinent, called Rebooting AI, which came out in 2019. One of the points I made is that deep learning is really good at perception. It's not perfect, there's some limits there, but it's really good at perception. But it doesn't mean it's good at every aspect of cognition. We also have common sense and planning and analogy and language and reasoning. It was not very good at things like reasoning and planning, and it still isn't. I made the point that AI is not one technique, but many, and that deep learning was just one of the things going on. We need to be looking at others. And I said, to get further, we're going to need to build deeper AI. And I referred to a paper that I published in February, or put online February of 2020. And I'm very sad that it was sort of wiped out by the pandemic. Nobody really read this paper at the time because, rightly, we were paying attention to the pandemic. But the paper got lost. And I think it's still incredibly relevant. It's called The Next Decade in AI, 4 Steps Towards Robust Artificial Intelligence. And I stand 100% behind what I wrote in that paper. I'll tell you a little bit about it. So one of the things that I argued for then, and I argued the last time I gave a keynote at this conference 3 years ago, was that we need a hybrid hybrid approach. And it seems obvious to me now, it was seemed obvious then, and I know some talks like John Laird's were around this, we can't get to AI by doing deep learning alone. Deep learning alone is good for some kinds of learning, but it's poor for abstraction. It's still poor for abstraction. I mean, how can you not understand the concept of current Prime Minister of Italy having been trained on the entire internet? I mean, something is wrong there. And on the other hand, classical AI obviously isn't very good at learning from large amounts of data. We have to build hybrid systems. One of the reasons, and this goes back to work I did in 1998 when I was a kid, is that they don't generalize well. They generalize a little bit, and that makes it incredibly confusing for people who haven't thought about this carefully. So people say, neural networks generalize, and we need generalization, so we're good. But we actually need two kinds of generalization. We need generalization to things that are nearby the things that we trained on, but we also need a broader form of generalization. And what I showed in 1998, and what I think is still my most important work, was that multi-layer perceptrons, which are forerunner to today, is if you train them on something as simple as the identity function for even binary numbers, they would generalize to other even binary numbers they hadn't seen before. I call that within training space generalization, but they wouldn't generalize beyond it to bigger numbers or odd numbers and so forth. And I showed that this was true of a whole bunch of models, and I talked about why it followed from backpropagation. And for a long time, nobody listened at all. I was accused of having a terrorist attack on AI in one of my peer reviews for the article in which I ultimately published this. But now I think everybody actually realizes this is a problem. Now we call it like distribution shift or something like that. And that is the fundamental problem, is if you move away from the distribution, well, it's not the only problem, but it is the fundamental problem. If you move away from the distribution, these systems just aren't very good. And so I made that argument in 2021 when I was here, and I've been making it for 30 years, and I'm getting tired of it, but it's still true. We still haven't solved it. That's the point. We are not going to get to AGI if we don't solve that problem. I also talked about knowledge and having abstract knowledge. We've made a little progress there. So like the particular example I gave then, what happens if you break a bottle into the liquid inside? GPT-4 would probably actually get that correct. But it's still a long way from having reliable enough knowledge. And part of the point that I made in this 2020 article and when I was here is that even having neurosymbolic AI, hybrid approach, is not a panacea. It's not the end of the story. Like, people are looking for one magic bullet, the one algorithm to rule them all. And they love LLMs as a candidate for that. We're never going to find that. We're also going to need large-scale knowledge, like Doug Lennett liked to think about. We need, for example, ways to represent knowledge about space, time, and causality. Like, what is now? We still find actually that hybrid models that build in some knowledge in special domains still do much better. So I gave the example then of AlphaFold, and I would give you the example now of alpha geometry that builds in some knowledge and is a hybrid system and does better. We need reasoning. We need also cognitive models. What is a cognitive model? Or Jan LeCun likes to call them world models, which is also a perfectly fine term for it. That's a model of the world where you have entities in the world. You know what the relationships between those entities are. You should have that in a transparent way so you can look up in some database who is the current Prime Minister of Italy so that you can then draw a picture of the right person. We still need to have these models of the world. Systems still, the pure LLMs really don't. So we still need cognitive models, reasoning, background knowledge, and relationships. That was kind of like the culmination of the talk I gave a couple years ago, and it's still true. And in Rebooting AI, we said it's a tall order, and paraphrasing, but if we can get past data and compute will solve all problems attitude and focus more on the foundations of our intelligent agents, we can do it. So in many ways, what I'm telling you is I stand behind what I said 3 years ago. Even though there's immense progress at some level, and even though there's billions of dollars more investment and billions of times more press and so forth, we're still actually facing the same exact problems as we were in 2021, even though in some ways the world feels like it's entirely changed. But I'm not done. I have a couple more slides, and then I'm going to tell you one other thing that really has changed in my thinking. So I won't go into all of this at length, But I gave this slide wrapping up when I was here a few years ago. I said we need rich cognitive models, we need extensive real-world knowledge, we need to work better on relationships between entities, we need compositionality, if there's questions I can go into that, we need common sense knowledge, we need reasoning, and we need better human values. I stand by all of that. That's still what we need to do. I don't think making big or large language models has made any progress towards this whatsoever. And that's depressing. I will call attention to Doug Lennett's last paper, in part because I got to help write it a little bit. It's really his paper, but he was very ill, and I helped him get it out. Getting from generative AI to trustworthy AI, what large language models can learn from psych, and I strongly recommend the paper. There was one more section I had a few years ago that only needs one update, and then I'll get to the new thing. So I imagined a protest march of the people assembled in this room. What do we need? AGI, when do we want it? Now. And asking the question, why don't we have it? And this field has been around for a long time. And I thought in terms of the actual godfathers of AI, not the people who were godfathers of deep learning who weren't around at the time, these people who were at the Dartmouth conference that launched the field, I said, if 66, and now the only change I've made is that 69 years ago, you went to Minsky, you went to McCarthy, you went to Alan Newell, I think was in the room, Herb Simon, and you said, I'm from the future, and I'm here to tell you that 69 years later, AGI is still really kind of far away. We haven't solved it. Why do you think that is? Like, you have this cool conference, and I'll tell you what, things are going to get better in a lot of ways, and you're still not going to solve it. And they would make excuses, because it's human to make excuses. They'd say, well, computers are really expensive. Our computers don't have enough memory to deal with it. We don't have enough data, although they didn't care a lot about that. We probably didn't get the money we needed. We didn't have enough people in the field that were interested. All of that has been 100% solved. Computers are way, way cheaper. I don't know, a million times cheaper, a billion times cheaper per cycle or something like that, trillion times. Computers have trillions times more memory. We have the whole internet, which they couldn't have even dreamt of. We have billions and billions, $200 billion have gone into AI, if you can count driverless cars. And everybody and their brother wants to go into AI. It's like the most popular major in most fields. So none of those excuses would have been right. So why is it that we don't have AGI? Here's what I said a few years ago. I think I stand by this as well. AI is harder than its originators realized. And actually, I should have added, it's harder than most of the people who are hyping the field right now realize, which includes CEOs of companies like OpenAI, not to mention any names. Second, most research is siloed. We have too little interdisciplinary collaboration. That was true in 2021. It's worse now, I think. Well, there's one way in which it's better. People are using LLMs in every field. There's, something may come out of that. But on the whole, research remains siloed. The pendulum has swung too far towards machine learning with too little focus on innate contributions. I still think this is true. We don't have people saying, how do I get this system to have an innate understanding of space, time, and causality, which everyone looking at cognitive development, well, most people looking at cognitive development, and philosophers back to Immanuel Kant and Plato and so forth have always said are important. We don't have systems that innately understand those things. So when Sora comes out, the graphics are incredible, to harken back to my earlier slide. The graphics are incredible, but you have things like people coming and going and dogs turning into 5 dogs and 4 dogs and 3 dogs, violating spatiotemporal continuity all the time. And I would add to this old slide from a couple of years ago, not only has it swung too far to machine learning, but it's swung too far to a single algorithm. We have an intellectual monoculture in which almost all of the research dollars and energy goes towards transformer models and almost nothing else. And that's insane, especially when you see how that bet is turning out. We still don't have enough common sense represented in machine interpretable form. I think there's an argument we'll be able to get LLMs to do that for us, but we don't have it in a sort of transparent and reliable way. And we still lack good mechanisms for integrating and acquiring abstract knowledge with machine learning. That's really why we're stuck. If we could solve number 5, I think we could get to AGI. And I know, for example, Ben and John are working on that every day. This is really where I think the core challenge is. Okay, there's just one more thing. There's something I completely neglected in 2021. A lot of the argument here is a lot of the things I pointed out are still true, but here's one I didn't think about. It is the moral decline of Silicon Valley and how that interacts with AGI. And, I kind of grew up in the don't be evil era, right? Google, I think, really did for a long time try to not be evil. They did some things I really don't like around surveillance capitalism. They were not a perfect company. But I think that they really did try not to be evil. In fact, they had LLMs and they didn't put them out because they knew that they might cause problems. And so we had a different regime. And then Satya Nadella came along right after he invested in OpenAI and after ChatGPT became popular. And he says, I wanted to come out and show Google that I made you dance. And that kind of changed everything, and not for the better, including it changed me. It changed my focus from academic research to thinking about policy, because it clicked on me. Especially, does anybody remember when Kevin Roose had a conversation in the New York Times with ChatGPT? ChatGPT told him to get a divorce, or Bing, sorry, Sydney, told him to get a divorce. I thought I had seen this movie before. The movie before was called Tay. Tay was a Microsoft product that was trained on the internet. They had a different version in China that kind of worked. And then they put it in the US and people got it within 24 hours or 12 hours to start talking like a Nazi and all this kind of crazy stuff. So they pulled it off the market, which I thought was the right decision. Like, it wasn't ready for prime time. So Sydney was not ready for prime time, and they put a couple Band-Aids on it and kept it up. And to me, that was just like a wake-up call. We are in a new era. And I've continued to feel that every day. Here's a cartoon from The Economist that captures a different version of the same sentiment. You have all of the major countries and companies saying basically, we declare that AI poses a potentially catastrophic risk to humankind, with one foot, and the other foot they're saying, and I cannot wait to develop it first. Like, how do you square that circle? Like, you have the CEO of Anthropic, Dario Amodei, saying that he thinks we might have AGI in 3 years and it might kill us all, and originally saying, and so I'm not going to release the frontier models, the ones that kind of on the edge, and now he's like, I'm going to release frontier models, and in fact, mine are better than OpenAI's. Like, I don't know how those thoughts live in one person's head at the same time. That wasn't the laugh line, that was a cry line. Okay. Then we have Sam Altman. I will refer you to the article I wrote in The Guardian a couple weeks ago. My view of him has steadily declined. I do not trust him, and I wrote about why. Maybe we can talk about the discussion. Then we have the huge copyright problem. So all of these are from an article that I did in IEEE Spectrum earlier this year. I helped Reed Southan, who's an artist, do a little bit of research. And what we found is that you could get basically trademark copyrighted characters routinely out of systems like Midjourney and DALL-E and so forth without even, and this is the important part, even asking for them. So you could say things like an Italian plumber and you get Mario from Nintendo. Now, if you said that to a real artist and they came back with that, you were trying to employ them, you would fire them. You would say, no. You're an artist. You come up with something new. You don't copy old stuff. I mean, never mind the legal side of it. Like, what are you doing, man? But that's what these systems do. I didn't update this slide, but Grok does this all the time. You can easily get it to like do Super Mario with a machine gun and all kinds of problematic stuff. So this is maybe the most important slide for this crowd that is an AGI crowd. I think of generative AI, all the garbage that I just criticized, well, that was too harsh, but all of the problematic systems that I just criticized, I think of generative AI as a dress rehearsal for AGI. We're doing a terrible job of containing generative AI, of making sure that it is safe and okay. We have no technical solutions to make sure that it is so-called aligned, even in simple ways. Like, one version of alignment is don't make stuff up. I forgot to use my favorite example of one of these systems saying that I own a pet chicken named Henrietta, right? They make up stuff I don't own a pet chicken named Henrietta, in case you were wondering. They make up stuff all the time. We can't say be truthful, stick to the facts, let alone, don't do anything dangerous. Like, we really don't know how to do that. And we have very little regulation, especially in the US. The only regulation that had any substantive chance of being substantive was weakened greatly yesterday in California. The Senate has not passed anything. We need to do vastly better by the time that we get to AGI. it's maybe okay that these silly systems that I'm talking about are not completely regulated and so forth. But this is a dress rehearsal. What happens when we get to smarter machines that can be incredibly exploited by bad actors? And so that led me recently to write a book called Taming Silicon Valley. It'll be out next month. How we can ensure an AI that works for us. This is just an excerpt from one figure from it. I'll give you a little more teaser of it in a second. But I talked about just the risks of generative AI, which is the biggest immediate risk of generative AI. I didn't talk about like extinction. Some people are worried about that. I'm not particularly. But even the stuff that we have that's not very good, partly because it's not very good, because it doesn't understand facts, it's actually very useful for bad actors. So bad actors are already using it for disinformation. There was a Russian plot that was recently, or not plot, but bot farm using generative AI was recently revealed. Market manipulation, there's accidental misinformation, there's defamation, there's non-consensual deepfakes, there's accelerating various kinds of crime, there's cybersecurity and bioweapons, there's bias and discrimination, there's privacy and data leaks, there's the intellectual property copyright issues, there's over-reliance on these unreliable systems, and there's enormous environmental costs I didn't have time to go into. That's all now with the systems that we have that aren't very smart. Some of it's because they're not very smart. So I went to the Senate since I saw you last, and I stood next to Sam Altman. Part of my decrease in trust is because of some of the things he said there that I later discovered were not true. And I made a bunch of suggestions. But in some ways, the core point is there are many risks from AI and not just one. And so we should not expect a magic bullet here any more than we should expect a magic bullet for making AI. We're not going to get one existing law that covers all of this. Agility is probably the most key thing, right? AI will change. Even if I think we've reached a point of diminishing returns for now, someday it will advance, right? It's a matter of having conceptual advances and so forth. They might happen this year, they might happen 10 years from now or 20 years from now, but they will happen. We need agility in how we manage this. One important thing is we need transparency. We need a full accounting, for example, of what data is used to train the current generation of models. We don't have that. We don't know them. We have a company called OpenAI that will not tell you what data they're using. Mira Murati went on television, with the Wall Street Journal, I guess, interview, and said, we use publicly available and private sources. That's all she was willing to say, and that's what they say in their papers now. Publicly available, first of all, is a weasel word to say some of it is stuff that we actually licensed, and some of it is stuff that is public domain for the taking, and some of it is not, but we were able to get it from some copy that's on Reddit, so we downloaded it, right? So it's a real weasel word. And then it doesn't actually tell you any of the specifics. And it matters because we can't fix it if we don't know what data goes in, because these systems are so dependent on the data. It matters because we don't know what bias is there. We can't, in general, mitigate the risk. Okay. We should have a full accounting of all AI-related incidents. Some people are working on this, but we don't have any legal obligation for this. We should have a full disclosure of all the testing that has taken place internally. I just cannot stop thinking about Ford Pintos. Some of you are old enough to remember, Ford knew that these gas tanks were going to blow up, but they did the calculation. They said, it's going to cost us a lot of money to fix this problem. And a bunch of people died. We have no idea really what OpenAI is doing for testing, for example. They write up some stuff. Do they write up everything? We really, as a public, have a right to know. We need an FDA-like approval process for large-scale deployment. I don't think we should ban AI research. I'm sitting here telling you how I think we could do AI research better by working on symbolic AI and so forth. But if you're going to deploy something to, let's say, 100 million people, you really ought to be able to make a cost-benefit analysis. You ought to be able to say, this is why this is of advantage to society, these are the risks, and this is why the benefits outweigh the risks. OpenAI sort of did that for GPT-4, but there was no procedure around it. And they didn't make the argument that the benefits outweigh the risks. They said, this is really cool stuff, and by the way, here are 12 things that could go wrong. And they talked about how their technology might destroy democracy, might destroy society, might lead to extinction. And they said, yeah, but we're going to do this anyway. Like, somebody should be like putting their nose to the grindstone, like, make the case here. Then we need to have post-release auditing by independent third parties. And I'll just give you one example. We know that people are using large language models to make decisions about jobs, and we know that they're what some people call covertly racist. It's almost certain, for example, no, let me say this carefully. There's a good chance, for example, that if you give your answers in African American English to a job questionnaire, that it's going to downgrade you. And I don't think that's right. It's against the law of the land. But I can't get the data, and nor can someone like Abiba Burhana, who would do it carefully. I would be lazy about it. Abiba Burhana can't get the data on how OpenAI's software is actually being used in hiring decisions. There is no mechanism. We need the government to make it possible for independent auditors to look and see what harms are actually taking place so that we can address them. We have almost nothing in the way of liability. The thing that makes me sad about what happened yesterday in California is the liability, some of the potential ways of making companies liable for what they've done were really stripped down a bit. We need to have layered oversight. So my favorite example of regulation of really dangerous but really wonderful technologies, airplanes, commercial airplanes. They're incredibly dangerous. They've crashed into buildings and many people can die. But on the whole, they're actually incredibly safe in practice. Well, why is that? It's because we have multiple layers of oversight. We have oversight over how they're designed, how they're tested, how they're maintained, what happens if there's an accident, and so forth. We should do the same thing for AI. There's no reason in the world that we should treat AI differently. It could actually be more dangerous. And we need scientists in the loop. I get very upset every time I see a big kind of like press thing with a bunch of government leaders, presidents, prime ministers, and a bunch of AI leaders, and no independent scientists who don't have skin in the game. And it happens over and over and over. And if that's all we get, then we get what's called regulatory capture. Some of you will know the term, some of you won't. Regulatory capture basically means the big companies write the rules, they keep out the smaller companies, and they don't really care about the public. We are headed directly for that. That is what has happened in the United States, is the companies have basically lobbied their way out of any regulation. And if there is any, then it gets watered down, which is what happened in California yesterday. And lastly, I think we need national and global AI agencies. We could talk about that in the discussion. So here's a summary from 2021, and I just added a few words in orange, and part of the point is almost everything that I said 3 years ago is still true, and I think that that's sad. COVID-19 should have been a wake-up call and a motivation for us to stop building AI for ad tech and news feeds and start building AI that can really make a difference. There's been a bit of progress in that. I love what DeepMind has done with AlphaFold, for example. On the other hand, my best guess is OpenAI is going to turn into an ad tech company. They're trying to get all of your documents so they can ultimately, if they want to, they can do precision targeted marketing, and that's kind of what it's going to be about. Deeper AI might be able to read, digest, and synthesize a vast and rapidly growing literature that's too big for individual humans to process. We still don't have systems that can read at that deep level. Hopefully, ultimately, optimizing the charge to develop better treatments, vaccinations, et cetera. There's a lovely paper, I haven't really read it yet, but I heard about it by, I guess, Jeff Clune and David Ha. I'm fans of both of them, about an AI scientist the other day, breaking down the steps you need. The problem is not with the steps you need that they describe, which are basically right, but the reality that generative AI can't, in fact, look at data and evaluate hypotheses properly. So we need better AI if we're going to make that vision actually happen. I'll skip the next one. Robots powered by deeper AI might be able to take on some of the risks that, for example, human healthcare workers faced in 2021. No progress on that. There's no, elder care robot that's really going to be able to help us, or robot of that sort, is really going to be able to help us in the next pandemic or whatever. And I would add, I should have maybe included this before, but generative AI hints at a bold future, but it's not reliable enough. And if there were hints of that in 2021, it's abundantly clear in 2024 that reliability is just not part of the generative AI scene. To get to robust AI that can operate in trustworthy ways, even in novel environments, we need to work towards building systems with deep understanding, deep conceptual understanding, that know what a current Italian prime minister really means, and so forth, and not just deep learning. The best way to get started on that journey is to focus on developing hybrid, knowledge-driven, reasoning-based systems with rich cognitive models. It's what we needed then, it's still what we need now. And the one thing I'm really adding here is that smart, agile governance for AI and more generally for AGI is absolutely key. I regret not having foreseen that 3 years ago, but that's abundantly clear now as well. I thank you very much, and I assume we have a little bit of time left for questions.
Hey, Gary. Thanks for the talk. It was very good. So just a kind of a question in your thoughts on a trend that I think we've been observing. So my talk yesterday highlighted, even as early as 1965, we've been in similar situations where we kind of go into this like tech cycle, this promise of the next big thing. And Adam Conover had also a very interesting interview with some tech journalists that big tech is caught in this cycle of over-promising the next big thing and kind of striving for bigger and bigger things, yet they don't actually have the technical expertise to tackle these very big problems. And voices such as groups as that I was advocating for yesterday have pointed out and warned of the dangers of the path we are going. So what are your thoughts on the fact that we keep repeating the cycle every so many years? And is it that perhaps the drama and even the debates that sometimes this creates is important for drumming up profit rather than actually tackling the fundamental issues? I was curious to know your thoughts on this historical trend.
I'm sure you know the famous phrase, the definition of insanity is doing the same thing over and over again, expecting different results. And that's kind of what we're doing here. And in fact, it's a pathological version because there's so much money at stake. It's going so hard in one intellectual direction and excluding many others. I see a little sign that we might be breaking out of that. I think that the economics are going to change soon. And a lot of people who invested not quite in the first round are going to lose a lot of money. So a lot of pension funds, for example, are not going to make their money back on OpenAI at $86 billion valuation, or at least that's my guess. And so money talks, and I think if there's not the revenue there, and it looks like there isn't, that will change things and maybe open people's minds. But I think part of what you're pointing to is the dynamic of hype is driving a lot of this, right? I think you're absolutely right. The dynamics of hype, Elon Musk made it very clear in what he did with driverless cars. There's no accountability. The media does not really push people on what they say. So, Musk basically issued promissory notes at no cost to him over and over again that we were going to have, a million robotaxis. And that made him a very wealthy man because a lot of people believed it and drove up the stock. I think, he himself has said that the value of the company is not as a car company, but as an AV company. There's no actual reason, in my view, to think that he's going to solve AV before Waymo or that he's going to do it soon. But by continually issuing that promise, he got a lot of money. And so Sam Altman's a very bright young man, and he picked up on that, and he's done the same thing. He keeps making promises. Like one of his recent promises didn't even make sense. He said that, he was envisioning a time when AI was going to solve physics. I don't even know what that means. It doesn't even make sense, I think, and it shows that he understands science even less than he understands AI. In my view, it's a category error. But he makes promises like that, and people line up. Naive people line up to write checks. And then there's how does the venture capital industry work? Why is it that people are making what look like actually bad bets if you take a step back? Well, it's because they make most of their money right now on fees rather than what they call the carry. So the fee is they get 2%. It's called 2 and 20. So they get 20% of any big profit, and they get 2% of the money they're administering. So if a venture capitalist can find a bet that sounds plausible to other people, they can make 2% on the bet. And if it's a big bet, that's 2% on a lot of money. And so you get some pension fund to make $1 billion bet, and you get 2% of that. That's a pretty nice year right there. You're done. And so there's every incentive in the world for these VCs to find things that sound plausible, and the hype helps make it sound plausible. So there are some VCs that are actually really good and in it for the long game, but there are a lot of them that are not. And they'll go with the hypey thing, and if the hypey thing is one that they can, quote, justify $1 billion bet or a $20 billion bet, they love that. And by the way, why are the pension funds doing this? Because the pension fund managers work on the same thing. they'll be gone by the time this all collapses. So I do think it will collapse. I think it will be bad for AI for a little while. It's going to leave a sting. We're going to have another AI winter, and I know you know that term. We'll get over it eventually. Like, I don't think AGI is impossible. Like, there's a bunch of people out there, posting on Twitter or whatever, who think AGI is never going to come. And I think there's no principled argument for that whatsoever. I think every problem that I talked about is solvable, maybe by people in this room. But we just haven't solved them yet. But we will. And we may actually have this kind of ricochet effect where for a little while people don't want to touch this stuff with a 10-foot pole. We saw that before, right? In the 80s, AI was super popular. There were a bunch of very high value companies, and within 2 months, the valuations for everything plummeted. It was, when I went to graduate school, you couldn't say that you worked on AI, much less AGI, right? And we may come back to a point where AGI is again kind of ridiculed because of how things are going down right now. So that was a long answer.
Sorry, so you do predict a maybe short AI winter coming? Sorry.
I think that there's a good chance of that. I can't fully predict the future, but I would say that if you look at the finances, OpenAI is a good example. They had an operating loss of $5 billion last year. You can't have an industry where most of the companies, except for NVIDIA, which is selling the shovels in the gold rush, are losing billions of dollars every year indefinitely. I keep thinking about Wile E. Coyote, right? When he goes off a cliff and he doesn't notice it, and then he notices, and then he falls. A lot of this is about psychology. We are off the cliff and losing the industry as a whole spent $50 billion on chips and doesn't have the revenue, and the stuff is not reliable enough to support the revenue. And so it's a psychological thing, and the psychology has started to break. When I wrote that piece last year, only a couple people were saying similar things. The generative AI is dead. Now, like every day, somebody's like, "Hey, Gary, did you see in the Financial Times, the Atlantic, the New Yorker, the Wall Street Journal?" Like everybody is writing kind of think pieces right now about how this is happening. And at some point, investors are going to be like, "I don't want to do that," and there's a little bit of a Ponzi scheme air to it. And when people are suddenly like, "I'm not putting my pension fund in an $80 billion valuation in such and such a company," then you have a problem. Then and one other sign of it is I've never seen this. 3 different CEOs of big billion-dollar capitalized companies walked and left their troops behind. When I sold my AI company, I made sure everybody got a good deal. We all moved over. We sold the company. I had offers to leave. I didn't take them. But 3 CEOs just did exactly that. They walked. Mustafa Suleyman, for example, walked to Microsoft, left his company behind. His company nominally had a competitive model. It was super well funded. He walked, presumably because he didn't see how he was actually going to make a profit. Then Amazon and Adept did a similar thing, and now Character AI and Google just a couple weeks ago, leaving lots of employees behind who do not take part in the big payoff and are kind of screwed. And so now there's also going to be a problem where people are going to go to startups and they're going to say, "I like what you're doing, but how do I know that you're going to still be here and I'm not going to be left holding the bag?" That's also going to contribute, I think. So no promises of anything, but if I had to bet, yeah, I think we're heading for an AI winter.
So, and I think you're hitting part of the problem right on the head at the end there, and you also had a couple spots there that I also think are key here, which is the interdisciplinary aspect and values. And the values is exactly towards the end there. And interdisciplinary just does not mean just technologically interdisciplinary, but where is discussions of how all of this is really impacting us as humans, and how are our human values being incorporated at a deep level into the AI. I don't think there's, in this group, I think it's a different system, but what I see with OpenAI is almost a shallowness of thought, not necessarily shallowness in terms of scientific thought, but in terms of those those deeper philosophical groundings, the philosophy of science.
There is an unfortunate attitude I won't speak to OpenAI specifically, but there's an unfortunate attitude in a lot of machine learning community in particular that anything that's written before 2020 isn't really that important. And that extends to like everything anybody ever wrote about ethics before then. And I mean, it's funny because it's true. Like it's a bitter truth. And this is not good. I think when the history of AI is written, this half decade is going to not be treated well. And it's going to be written as a tale of hubris, where people got these tools, got an enormous amount of power. I think I'm getting a cue that I should probably wrap up. I don't have any more questions, but the people got an enormous amount of power, got high on their own supply, didn't listen to anybody else, and it didn't turn out so well. And in fact, the edifice collapsed. They made the whole field look bad. Like, it doesn't have to be that AI is run by people who basically want to do surveillance capitalism and don't, we could imagine a better world here. I mean, Larry and Sergey, I think, had a better attitude, and we could have more people like Larry and Sergey at the top and fewer people like, I won't name, but you know who I'm thinking. So like, it could be different. Maybe it'll be different again. I can hope that it is. Like, I wouldn't talk about this stuff if I thought it was completely hopeless. I would, borrowing a line from Jerry Fodor, but changing the nature of the boat. He would go sailing, and I have a powerboat. Like, I would just go off on my powerboat and be done with it if I thought that it was completely hopeless. I think there's still a chance. That's why I'm out here giving talks.
Gary, my question is about the future of regulating AI. If you're serious about taming Silicon Valley and I guess tailing some of the wilder impulses of the open source community as well, what's going to happen given the apparent failures or the dilution of the attempt to regulate things in California? And there's been such a huge pushback about that. Almost everybody I know has been saying this is terrible legislation, let's hope it fails.
There's so much misinformation about I wrote an open letter to Fei-Fei Li a few days ago about some of the misinformation that I thought even she conveyed. And I have a lot of respect for it. I was disappointed to see that. There's been a lot of misinformation about the regulation. There's a second thing there, which is we really need to think about bad actors. So I am fond of open source for many reasons, but it is also the case that we are giving everything away to everybody. And I think that there's a cost to that. That's probably where Ben and I would, most disagree, would be about consequences and how to think about that. The short-term biggest problem, I think, is that democracy, I think, is under threat here in both direct and indirect ways. Mostly I'm worried about elections in the near term. There's been an uptick of misinformation even over the last couple of months. And Grok, even though it won't do what you ask it to do all of the time, is a tremendous tool for deepfakes and stuff like that. So the fact that we don't even have decent rules around deepfakes and misinformation and so forth is disconcerting, let's say. I see that Ben wants to ask a question.
Yeah, I think on what needs to be done to get to AGI, I think we substantially agree. I may think I'm further along the path to solving that than you think anybody is right now. But in terms of the sort of list of capabilities that human-level minds have and currently deployed AI systems don't, I think we agree.
Yeah.
I'm thinking through whether there really will be another AI winter, and I suspect there won't be. Really, I just want to briefly bounce my thinking off you and get your response to that. So it's clear there's a bubble in LLM company valuations and generative AI company valuations, and the investors are going to get burned out on that, no question. My view from working on a bunch of practical applications using LLMs is that LLMs and other deep neural networks, when intelligently integrated with other technologies in vertical market applications, can do amazing stuff, right? I'm seeing that in music, in biology, in finance, and things I'm working on. So I guess my take on it would be that companies doing that are going to prevail and keep getting investment, and technology is going fast enough now that before a long winter could set in, you're going to see a bunch of successes weaving these technologies together with other technologies to do really useful stuff, while at the same time, AGI R&D, like we see at this conference, will keep delivering at least demos that look cool and some real advances. So it seems like there's the recipe for the LLM bubble not to lead to an AGI winter, and that seems not to be your perspective. So I'm curious why.
I understand the perspective, and you could be right. I mean, as I said, I can't predict with perfect certainty. And some of it is an economic question, right? So there are applications of LLMs. As you say, the LLMs can be integrated and so forth. Some of it's a question of economics. So like, how much money is there in these applications that are not the thing that everyone was promised about? And how is all this going to shake out? So if the sort of narrower applications that you're describing make a few $1 billion a year, but people have been investing, imagining trillions of dollars in payoff, it's a question of like how people feel about that. I mean, some of it's a vibe. Buttigieg had that line about politics being mostly about vibes. Well, so is research to a remarkably large degree. And so is the economics of investing. It's about vibes. And so what you're asking, I think, is a totally fair question. There's definitely some real world applications. Some of them are important. And, you know, it's like if there's one really good biotech application, maybe that justifies the whole thing and it forestalls the winter. Or maybe it doesn't. And it's about how the vibes go and what the kind of economics there of like all the cost of the chips versus the benefits. And like, it could be that we have a winter when we shouldn't. I mean, it could be that, you know, there's a couple of really nice medical applications that don't make that much money, but really like save a lot of lives, but because they're like on rare diseases, they help people that couldn't otherwise. I'm just making up the example, but you can imagine stuff like that where, hey, we should actually keep doing this, but people are like, yeah, but the chips are too expensive and I don't want to do it anymore. I don't know. Like, it really is an interesting and open question where it will go. So I think we actually agree on the parameters there, right? There is a bubble around generative AI. It is going to have an impact, and there are some practical real-world applications, and we're both trying to guess the balance of that, and neither of us really know, and you know, it's hard to know. Thank you very much. I'll be around.
Thank you very much, Gary.
Thank you.
That was great. Thank you.